Seeking appropriate clothing.
So, relatives, and in that box, homes.
What are you doing? Señor, pedimos.
Gabe Kaplan.
Victoria. Los partidos arrancando.
Being successful very long. It's just, it'll wear you out.
You can tell them that all you want, but they're not going to listen to you until it hits them right in the face.
Gets worried about because he's had 3 concussions now in the pros. He had at least.
You don't want that, man. You don't want that. Tonight in the American League Championship Series, David Price tries to win a game. As good as David Price is, he's never won a game in the playoffs. But he's going in the offseason, he's going to ask for $200 million. His agent's going to ask a team, we need $200 million. And if I were a team, I'm like, hey, can you win a playoff game? Tell you what, if I were a team, I said, I give you a $25 million incentive if you win a playoff game for us.
Tigres y América, equipos de nómina.
This is the Philips car radio NX344V as in Victor /10. This radio was sold in 1953 and 1954, so it's pretty old. It is obviously a tube radio. It has 4 tubes, and if you stay tuned, I'll show you the insides later. It runs off 6 volts or 12 volts, can be selected from the inside. And obviously it has a radio vibrator to convert that to about 250 volts inside for the supply voltage for the tubes. Now this particular one was completely restored by me. It didn't look as nice as this when I got it. Everything is refinished, the case is painted and everything. This is powder coating, and the inside also took a lot of work, and like I said, once we have it opened up, I'll explain you what was done to it. The radio covers medium wave and long wave. Long wave used to be popular in Europe in those days. Nowadays I don't think there's many broadcasters left. Good thing is that here in the US we still got a lot of medium wave broadcasters. So there's a lot of things to hear.
Te escuché, Raúl. Sí, te escuché.
Corporate Investment Business Brokers, Southwest Florida's leading business brokerage.
Radio works very well now that it's all restored. It's actually more sensitive than the car radio that's in my 2015 Ford. So works very well, sensitive and easy to operate. Now in those days, as you can see, it was very easy to hook up a car radio. You basically got supply voltage. Here you see the voltage. We have it running at 12 volts and 1.5 amps is what it draws. So that's all that's needed. And of course a speaker. I'm using a simple computer speaker. And an antenna, which is a wire antenna. And that's it. I mean, if you look at modern car radios, there's like these complicated 20-pin connectors to it. And that was not the case in the old days. The downside was, of course, that it was pretty big. Car radios were not small in those days. And that is a challenge when you have to build it in. This particular model was used a lot in like VW Bugs and some other car models from those years. Most of them are running off 6 volts. That's the reason why this radio can also handle 6 volts. But like I said, works quite well. Here you see the antenna connector that is still the same as what it is today, same type of connector. This is a little hatch that you can, there is a trim capacitor in there. I don't know if you can see it, but you can tune the antenna to a better optimum to make it even more sensitive. So it works pretty nice. Let's have a look at the rest. Alright, show you the bottom. Maybe interesting to talk a little bit about the dial. As you can see, the dial is in meters, not kilohertz. And 200 to 500 meters is medium wave, and we got 1100 to 2000 meters for the long wave. Here you see the bottom. That's also completely refinished. This is actually the way it originally was, a little terminal block. It looks kind of weird, but that's how Philips did it. The label, there are 3 of them, 2 on the side, 1 on the bottom. The label I completely redid with a graphics editor and then printed it. It has the original serial number. This is what was on there when I got it, but it was hardly readable. But because there was 3 labels, I was able to reconstruct that number. But so this label is reprinted with a laser printer. It is not the original. But as a result, the radio almost looks like new. I'll take off some of the wiring here. As you can see the rest. This is the end. This is the bottom, as I said. This is the sides. Now, there used to be a little slider here to switch it from medium wave to long wave. That wasn't on there anymore. You can still get to the actual switch with a little screwdriver or whatever. So it's still possible to turn it to long wave, but like I said, there's no use doing that because there's nothing to hear there. But it's not a big deal. But for the rest, it's practically like new again. Alright, let's show you the insides.
Even get voicemails transcribed. Join over 150.
Alright. Well, we just wanted to show you the inside of the radio. As you can see, it is a tube-based radio, obviously, from 1953. You couldn't expect much else. And the tubes that we have is, this is the RF and mixer tube. ECH42, it's a rim lock tube. You can see here with the jack at the shroud in which it plugs. This is the IF tube, EF41. This is the detector and pre-driver for the audio, and EAF42. And there we see the PA tube, audio PA tube EL42. And like I said, all of them are rim lock tubes. The radio is built up in an RF section and a power supply / audio amplifier section. And as such, it's a single unit. Lots of radios of those days were split in 2 halves. Here they built it all in 1 unit, which was kind of a nice touch. One thing that's kind of interesting is that the radio is permeability tuned. There is no variable capacitor in there, for the tuning that is. Here you can see the 2 coils. There are these aluminum cylinders, a little bit hard to see. This particular one is for the local oscillator. This particular one is the RF coil, the input RF coil. And the local oscillator always runs 457 kilohertz higher than the tuned input. As you can see, there is a gear that moves the coils inside the cylinders up and down. I guess that was done to make it more robust against vibration, you know, when you drive around. And a variable capacitor is never balanced, mechanically balanced. For a stationary application that doesn't matter, but for a mobile high vibration situation, that is a problem. And that's why this was done in this way. I would assume that's the case. It works very well. The local oscillator is also very stable. You know, it's a tube radio. You would think it would drift after a while. There isn't any drift. There must be some kind of compensated cap in there, because temperature compensated, because it doesn't drift at all. The radio can do long wave and medium wave. Long wave used to be popular in Europe. I don't think there is many long wave broadcasters there anymore. Of course, in the US there aren't any, and there never were. So that's useless in the US. But in Europe that was popular, and there might still be a few left. I don't know. In any case, we're located in Florida, so when I turn it on here, I don't hear anything coming across the Atlantic. Maybe when there is particular propagation, but I haven't heard anything. Here you see the inside of the case that we took off. Here is the a diagram that shows you how to set it from 6 volt to 12 volts DC. This here is the actual diagram, electronic diagram. This particular label I remade from scratch. The old one was in poor condition, so with a graphics editor I basically built a whole new one that is identical to the original. This one was scanned from the original and then restored with the same graphics editor to bring it to near perfect condition again, and then it basically was adhesived in there and lacquered off to protect it, just like it was in the original situation. Now, quite some restoring was done here as well. For instance, the antenna connector, one of those typical car radio jacks. That one was completely rebuilt because the old one was rotted away. For the rest, the thing was in pretty good shape. All the resistors that are in here are replaced, because the old ones that you see here, a few of them, this particular kind of resistor drifts away after 40 years. They're not at all anymore what it's supposed to be. For instance, this is 39K. I think it was close to a mega ohm. The same is true for these capacitors. These are the tar capacitors that Philips used to use in those days, and they go bad pretty fast. They basically start to leak. I mean, electrically leak. They build up a resistance. For instance, there was one inside that drives the PA, that connects the PA with the driver. The anode of the driver is connected to the first grid of the PA with a 1 mag resistor to ground. So if that resistor starts to leak, if that capacitor starts to leak, the grid is pulled up to the positive, and the PA starts to draw way too much current, which is exactly what had happened with this radio. So everything was bad. Every capacitor, every resistor was bad, which was practically all of them is replaced, which was a lot of work. Here you got a better view at the back section. Again, everything was replaced. These two capacitors, which make the power supply, the primary power circuit resonant, were replaced. This is another filter cap that was replaced. Resistors were burned up, so they were replaced. And there's another big filter cap there that was also replaced. Try to find caps that are as much as possible like the original. So not the ultra modern one that are so small you can hardly see them. These look like the original ones. Only one mod that I did, you can't see it here, but there is a diode here. If somebody reverses the voltage, the fuse will blow. So that's basically reverse polarity protection, and that's in there because of the vibrator. This is the original vibrator can, but what's in there is a solid state vibrator. And the original radio was capable of running on positive chassis as negative chassis voltage. With the vibrator, electronic vibrator, that is not the case. So I have set it for running only with negative chassis, and that will protect the diode will protect the vibrator. What's in there is a little board. This particular one is not populated yet, but that's basically the size of the board. Fits in there perfectly. It's a I set it for 100 Hertz, which was also the original vibrator. US vibrators are usually at 60 Hertz or 115 Hertz. Philips run them on 100 Hertz, twice the AC 50 Hertz, I guess. And that's what we have set this vibrator for, to be as genuinely as possible in terms of the operating conditions. You see, completely rebuilt. The filter cap, the original high voltage cap, weird enough, was completely fine. I had not expected that. Here's another one. So I did not have to replace those. For the rest, just about every cap was bad, but not that one. So that was good. That is still original. The radio can be set for 6 and 12 volts, as I showed you earlier. Maybe you were able to see that on that label. Right now I've set it for 12 volt. It can still run on 6 volt as well. So if you have a real old VW or a Renault, that might still work. This radio was used mostly in VW Bugs and also in Renault Dauphines, which is a radio. This is a car from the 50s that you don't see anymore, but it was also used a lot in that particular car. Okay, that's it. The Philips NX344V/10. Thank you for watching this video. This is a few more labels that I had printed that I didn't use anymore. By the way, if you're restoring one yourself and you need the artwork for the labels, I'm more than willing to email that to you, so let me know. Thank you for watching this video.